Hi, everyone. Thanks for joining us for the next episode of Model Mondays. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and hosts to answer live. Our session is being recorded and will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over to our host for today. Thanks for joining.
Hello and welcome everyone to another episode of Model Mondays. This is my first time hosting, so I'm glad to have everyone around. I'm seeing my teammates on the chat already. So we have Nitya and Lee who will be moderating the chat. So feel free to ask any questions that you have. And the chat is open for anything that you want to discuss, whether you're telling us where you're joining from, like there's someone joining from Mexico, that would be awesome. Also, you can also ask any questions that you have for our speakers. As an introduction, I'm Bethany Japchumba, and today's session is about document processing. So we'll talk about how the new Mistral Document AI works and how you can be able to leverage on it to use it for your document processing. As usual, as the format of this session is a live stream, so we'll have this session with a spotlight of what's been happening, what the new things that have been happening. Next, we'll go to a discussion around the Mistral Document AI, and finally, we'll wrap it up with customer stories. So you'll get to see how customers are using Microsoft in their different applications. First off, we'll start with the weekly highlights from Shamila. So she'll be talking about what are some of the top 5 new things that came out this week and what you should be looking out for in terms of what you can be able to leverage on and how you can be able to use them. So yeah, I'll pass it over to the moderator to have Shamila's video on. Yeah.
Hello, everyone. Welcome back to this week's highlights on Model Mondays. And just like every week, we have 5 new highlights to share. And on each new highlight, there is a QR code that will either take you to a blog where you can learn more, or it'll take you to a GitHub repo with a code sample, or it'll take you directly to the model card where you can try out a model. So let's jump into this week's highlights. The first highlight is around agents. So this is a blog that a new blog series that we have started around agentic AI, and it's called Agent Factory. And what we this in this particular blog, they are talking about how reliable automation requires agents that reflects on their work and plan like a multi-step process, collaborate across specialties, and adapt in real time, and not just execute single steps. And it actually this blog outlines like the 5 design patterns that lets AI agents not just tell but do using tools. And this, think of it as AI with initiative, accountability, and teamwork built in. So not just a talking head, but a whole think tank on Auto Boost. And this is just, as I said, a first blog in a like a multi-part blog series. So let just go ahead and take a read of this Agent Factory blog. Okay, now the next highlight is around text PII, privacy, personally identifiable information, and text PII just got a new preview release on Azure AI language. It now supports redacting everything from date of birth to license plates with full support across major European languages like French, German, Portuguese, Spanish, and more. Plus, bank-specific entities like UK's can sort codes. UK's sort codes are now recognized with better accuracy. It's like giving your AI a global privacy suite with more and more languages. Another big announcement around models, Claude Opus 4.1 is now in public preview for GitHub Copilot Pro and enterprise users. So this model brings better logical summaries and tool assistant thinking to coding. And yes, it supports Ask mode in VS Code. The old Opus 4 is now on its way out, giving way to a sharper, more context savvy coding buddy that helps you think and code better. And the next two highlights are going to be around document processing and doc intelligence. And this is not unintentional. We do have our spotlight episode with Mistral AI on doc intelligence. And today, the first highlight is around Azure Document Intelligence. And Azure Document Intelligence and Content Understanding is now leveraging an even more robust and proven computer vision algorithm to ensure the fundamental accuracy and consistency across doc intelligence that enterprises demand. And we all know that parsing tables from documents is usually a mess of mismatched rows, but not anymore with this new update. Azure's Doc Intelligence actually it nails separation lines even when they are visible using synthetic data and GPU friendly models. It's 94 to 97% accurate across Latin, Chinese, Japanese, and Korean, all while slashing latency from 250 milliseconds to under 10 milliseconds. In short, it sees the invisible lines and scores high on speed too. Again, as I said, the last two highlights are on doc intelligence. And so the final one is around our latest partnership with Mistral AI with by bringing Mistral Document AI into Azure AI Foundry. And if everyone is familiar with Document AI, it actually transforms PDFs, contracts, and scanned documents into structured JSON outputs retaining tables, headings, and even latex notation. It's serverless, multilingual, secure, and plays very nicely with Azure's governance tools, making regulated industries like Europe's sovereign cloud breathe easier. And that brings us to the end of this week's model highlights. I will hand it back to Bethany. Thank you.
Thank you so much, Shamila, for that. It's nice that most of the highlights are regarding document processing. What is like one of your top highlights for this week?
I mean, of course, we launched Mistral Document AI towards the end of last week, and that's kind of my highlight. And we do have this has never happened in Model Mondays before, where we launched a model and immediately brought a speaker from from that model launch onto our Model Monday show. And it's nice to kind of follow up with that highlight with our spotlight speaker as well, who's from Mistral AI. So I'm kind of excited to learn more about Mistral Document AI.
Yeah, that's definitely the first time you're saying this. So I'm also very, very excited to see now it in action. Like, how exactly does it work, and how can you plug in with the rest of the Azure ecosystem? One thing I also liked was how you mentioned that it plays really well with all the capabilities already on Azure AI Foundry. So yeah, very excited to check it out. So let's get over to the weekly spotlight. As you've mentioned, today's spotlight is by Param, who will be taking us through the document processing that was just launched this week. I'll have Param introduce himself. He's from Mistral. So that's also very interesting because it's not just Microsoft. You're partnering with Mistral on this. So Param, you can go ahead and introduce yourself.
Hi, thank you. Hi, Param Singh. I'm a partner solution architect with Mistral AI.
Yeah. So a question to you, probably Shamila, you can also answer. What is like one top use case you can see the document processing come in place? Like, what's one place that you see many people trying to use this Mistral Document AI in the processes? Yeah.
I dealing a lot with like printed forms or various sets of unstructured data that ultimately end up in something like a retrieval augmented generation type solution, where you're able to extract that. So in addition to just being able to do the OCR extraction out of those documents, being able to extract them in a structured way or doing sorts of introspection and adding additional pieces of metadata or even asking questions about the document, you're able to do all of that with Mistral Document AI in one API call.
That's interesting. Shamila, any top use cases you're seeing?
We haven't started, like we just launched it, and this is something that we are curious to learn more from our Model Mondays folks who are watching Model Mondays. I know last week a few folks requested for document processing, like more deep dive on that. So I'm curious to learn more about your use case as well. And we just launched it. We are going to watch over the next few months to see what's going to happen, like who's going to use document AI, what are the main use cases. And most likely we'll be bringing this to Ignite as well, which is happening in November. So that's kind of our next few months, like what we are planning to do with document AI.
Yeah, I'm super excited because it's very new. And if you're in the chat and this is something really exciting to you, you can tell us what are the ways you see you can implement this in your workflows and use it in your day-to-day. Okay, we can now head into the demo. So I'll pass it back to Anna to give us the video for the demo.
Time to view our demo today of Mistral Document AI on Azure Foundry. Before we get into the demo, just want to highlight that a lot of the kind of technical details and kind of more elaboration on what's going on and how to use the API are available on GitHub in the Foundry samples GitHub repo. Okay, so with that, let's get into the demo. I've got just a very basic Streamlit app up and running that we'll be calling the API and kind of showing our results to help us out today. At its heart, Document AI is very, very good at OCR. And we're going to step through a couple of examples of watching it extract things from images and a couple documents. And we'll go into some more advanced capabilities with our image annotations and document annotations. So with that, let's start with something I run into pretty much every day, and that's receipts. So here we have a picture of a receipt, and I'm going to try using the API to extract this information. So let's go into Browse Files. Let's pick that one, open, and let's hit Extract. All right, so we're calling the API with just its most basic configuration. I'm returning the markdown that comes back. I think for this, it'd be very interesting to take a look at the actual response from the API itself so you get a feel for what it looks like. You'll see everything comes back in JSON in a structured way, so it's very easy to retrieve this information programmatically. And here we've got our receipt details, right? So it's American Express, it's got the date on there, everything's great. So this was a very basic one, but in your day-to-day, working with receipts and printed information are a core use case. Whether it's machine printed or not, that information is still on a piece of paper somewhere. Getting out of the images using OCR is a great way to go. Okay, so with that, let's try something a little more advanced. In this case, if we have any fans of history, it wouldn't be Mistral without mentioning Paris at least once. Here is a letter Thomas Jefferson wrote while he was in Paris to his nephew, Peter Carr. This is available, I believe, on the Library of Congress website. So let's try extracting the text from this one. All right, so let's open it and let's hit extract. All right, so just like with the receipt, this particular sample, right, or example, is retrieving all the information that's on that page. We even got some of the sort of penciled markup. If I let me pull that up real quick. All right, that has been scrawled on here, so it's picking up a lot of it. And yeah, it's Thomas Jefferson at his very best, pulling out his interpretations and things his nephew should work on. It's very cool. Okay. All right. So let's, so we've taken a look at, a printed receipt. We've taken a look at something that's been handwritten. Something else to call out is the capabilities that we've got with tabular information. So for this next one, I'm going to pull out from our friends at Microsoft an 8K statement. Right, so everyone's seen these. They usually have a lot of tables in them, like such. So let's take a look at if we can extract this information using our API. Let's browse files. It's a nice long file name there. Let's pull that out and let's hit extract. So again, all I'm really changing here is the kind of configurations that we've had with the files. For any of the files and images that you're submitting to the API, they are going in as base64 encoded objects. So let's just take a look at this. I think we had some stuff on page 5. Just go through that, and here we go. In nicely formatted Markdown, we've got our tabular structure and the information that's contained in that 8K document. So that was very cool. So we just took a look at 3 kind of different use cases. One is, printed machine copy on a paper, right? That could be a receipt or a form. With that first receipt I had. The second thing we did was something that was handwritten, a pretty old document that the service did a really good job of extracting information out of. And then third, we had a document that sort of mixed types, but mostly tabular information in there, and we're able to pull that out pretty well as well. And again, you get all this stuff in the response in Markdown format, right? So if you're doing programmatic extraction that's feeding something like a retrieval augmented generation system, that comes in very, very handy along with the associated metadata of what page it's on and so on. So now we're going to switch into kind of outside of just basic OCR, 2 things that are a little unique to our service and our API. One is image annotations, and the other is document annotations. So with image annotations, that's conducted across every image in every page of the document that you submit to our service. And then with document annotations, it is essentially against all the pages in the document as a whole. At launch, we're going to have a limit of 8 pages that you need to be aware of. So with that, let's pick our next sample. In this case, it's our paper for one of our 7B models. Right, and we can take a quick look at what the document looks like here. All right, so yep, pretty standard latex markdown with some table information in there as well. So prior to all the other things, we didn't have a document with really a lot of images in them. Something that the service can provide is in the response, we can actually return base64 encoded images for display, or if you're going to extract them to do additional things with, you have that ability with this. We're also going to go ahead and check image annotations and document annotations here. I'm going to provide those with a JSON schema. Now, I'm going to paste this in for convenience. You can either compose your own, or if you're somebody like a Pydantic user, you feel more comfortable with that, you can use that to generate the schema and then just paste the schema in as you're passing the API request. So again, for convenience, I'm just going to go ahead and copy a schema I already had set up for both, and I'm going to go over what's in here. So that's one, and I promise I'm going to get to the other one really quickly. So just to step through it, this is nothing special to us. This is standard JSON schema. We're including, a description of what we want the model to do, right? So in this case, we're going to be retrieving something called an image type, right? And we're telling the model is that tell us what the type of the image is and return it as a string. And then we're also asking it to provide a short description of what the image is. And then in the document annotations, remember, this is run across the entire document as opposed to the image annotations, which is run across every image in every page in the entire document. So for this, we're asking us to retrieve the language of the document. So what language is the document presented in? Provide us with a brief summary. I'm telling us to give it to us in English. Chapter titles, let me know how this is organized. And translation, translated in French, the summary specifically. Again, this is highly customizable. That's one of the big reasons of why I'm presenting the schema this way. You can put as many fields as you want, right? If you wanted to have nested objects with the lists, that sort of thing, you can do that as well. The kind of key takeaway is if you're extracting documents and all of this stuff, it's all done with one API call. So with that, let me hit extract. This is going to take a little bit to run. All right. And understanding what's happening. As we're submitting this, we're asking the API to look through the entire document, return our markdown like we were doing all the previous examples. We're asking us to also return the images that are included in this document in base64 format. We've specified image annotations, right, to tell us what type of image is in there and a description of the image, as well as across the document giving us, a summary, what language the document's in, what are the chapters in the document, and then also do a French translation of the summary. So let's let the cookies bake for a minute. And here we go. So here, just like with our paper and all the other stuff we saw before, right, we see the rendered markdown. In this case, I have stitched or combined the base64 output of the images that are being returned with this handy flag. And now we're presenting it in markdown format. So this is great if you're reformatting, or again, if you're going to put that information into another system, like in use of search or retrieval augmented generation. And we also have annotations. So let me go first to the document annotation. So these are across the entire document that we just presented. Remember, we asked it what language, so the model's extracted English. It's provided us with a summary. It's also provided our chapter titles, and then a translated summary in French, right, as we instructed in the description fields. Now onto the image annotations. If we go into, again, so the structure of this, I think we covered last time, right? So for every page, we're getting a set of information back. In this case, we've got 8 pages, right? And in each page, we're going to have a list of images, and then in those images, we're including, here's the base64 image that's coming back, and the annotation we provided with this. So we're getting our image type, and the first page it's a logo, and then a short description. So that was a lot of information. Thank you for staying with us if you're still there. And again, a lot more information is included in our write-up in the GitHub samples. Please have a look and let us know what you think. Thank you.
Thank you so much, Param. That was so impressive. Before I go to the questions that we have on the chat,
Sure.
One thing I want to emphasize on is we have our Model Mondays GitHub channel. So Lee and Nitya have posted the links to the GitHub, to the Discord link. So if you want to go to Discord, you can click on the link and then our channel, the Model Mondays channel. And at the end, I'll tell you about our AMA that's coming up on Friday. So if you want to learn more about this, yes, you can find us there. So I'll ask 2 questions. The first question we had was around image and document processing, but I feel like you've already captured that in the presentation that you did in the entire demo. It was really, really nice going from just basic OCR to now the encoding and everything else. So there's one question by Mandy who's asking, can you use a photo of my salad bowl and calculate the calories? This is such a specific use case. So yeah.
I think we should give it a shot.
Right?
I think you should be able to ask questions of some of the images in there, specifically with the image annotations. If this particular model isn't to your liking, we have a lot more that are available on Foundry that can definitely do multimodal input, but I would give it a shot just to try it out.
Yeah, definitely. So probably if you come on Friday, that's one of the demos you need to try out. And then the second question is around GDB. So Azure Data and Real World Scenarios page is asking, GDB, that is geodatabase, can this handle map data stored in an esri.gdb file, like based on a source code instead of like an actual image. I'm not very good with the geodata and everything, but I guess you understand the question if you can be able to use it for different files, especially in terms of map data that's stored in a .gdb file. So is that possible, and can that be added as one of the retrieval details?
That sounds like a really interesting use case. So if the GDB file, I'm not familiar with that, I've done GeoJSON and a few others, right? If it's kind of similar in that regard, you might not need a document processing API or solution in general. OCR might not be the right thing for you. However, again, models that are context aware, that understand formats and things like that, we do have Mistral Medium, Mistral Large that are available, and those I would definitely say let's give it a shot. Instead, like if the map data is visual, that might be something to try with this or other VLM type models that we do support and provide.
Okay, thank you so
That's
much
okay.
for answering. Yeah, that's okay. Thank you so much for answering those two questions. We have
Okay.
a lot of other questions coming in, so if you can
All right.
go to the chat and respond to them. But as I've mentioned, on Friday, we have an entire session around just asking questions about this, so you can join us then. And in case we have any time left at the end, I'll also invite Param back to come in and ask the questions and answer the questions you have. As mentioned, you can go to this page around the Mistral AI document where it shows the collaboration. Sorry, it shows the collaboration and how you can get started with Azure AI Foundry and Mistral Document AI. And with that, we'll go next to our next story, which is our customer success story around Oracle. And in here, we talk about how Oracle Health is using fine-tuning to be able to now make their projects and experiments better. So I'll hand it back over to Anna to give us the video, and if we have time at the end, we'll answer a few more questions. Over to you, Anna.
I'm Shri, and I lead clinical AI at Oracle Health. And over the past year or so, my team has been building and shipping agentic solutions to doctors and nurses to use at the point of care, which is hospitals. So we're pretty proud of it. And I guess the Azure OpenAI team has been a great support, from getting us into the previews of various models, all those nice quotas, just keep them coming. So today I'm going to share one of our fine-tuning journeys. And hopefully you can pick up like what model choices and trade-offs that we have to do. And a lot of developers actually ask me, hey, where do you need fine-tuning? Isn't it too costly? Both time-wise and actual cost, right? Dollar cost and so on. So yeah, hopefully you can get some insights. I guess first, I have a bunch of like mandatory input tokens for all of you to process, disclaimers and such, but it's okay. No need to produce any output tokens. All right, so at Oracle Health, our goal, one of the key goals at least, is to ensure clinicians actually do what they love doing the most, which is caring for patients. And we want the agents to take over some of the administrative burden. When I say burden, think of documentation. We know doctors have to spend like an hour to hour and a half every day just writing notes and looking for information as they prep for their next patient. Sometimes they have to find information in multiple places and stitch that by themselves, right, in their brain, essentially, to get to the answer they're looking for. And there's a ton of data entry as well, right, like for discrete things, like when someone comes in and asks you, hey, how is your pain score now? They have to take it and enter it into the electronic health record, right? So that's a lot of work, and we want to have the agent significantly automate these things, but then by always keeping the healthcare provider in control of things using a human-in-the-loop architecture, because we don't want to create any patient safety risks, right? So the solution to our vision is called the clinical AI agent, right? It's a multi-agent architecture that's deeply aware of the provider context, like what do they do, what is their specialty, what is the usual demographic of patients they see, and also deeply understand the patient. What is going on with the patient, problems, and like what meds they're on, all that stuff, to proactively drive the clinician workflows so that they're efficient, right? So it can cut down the time that they spend on all these administrative tasks by 1 to 2 hours a day, which is a lot of time, right? So without taking any more time speaking, I'm going to get to a real demo. I'll first log in. I guess for this part, I'll have to wear my fake doctor's hat.
White lab coat.
Oh, wow.
That's okay.
All right. Since I'm a doctor, I'm trying to figure out how to, I guess,
Do you need IT
charge my
support?
computer. I didn't realize it ran out of charge, or I guess that power is not active.
Uh-oh.
All right.
It is not on the screen yet.
No, it's still working. And this is the time where we tap dance.
All right. Let me try logging in.
All right. Okay.
Again, this is not a recording. We're doing this live.
Yep.
If it was a recording, it would be going more smoothly. And as you're logging in, is this something that's actually in use today?
Soon. So some agents are in production. Some are going to be there very soon. So here, like I said, I put my fake doctor hat on. I'm Shri. I'm an outpatient physician. I see about 15 patients a day because they go in like 30-minute appointments, right? And I have usually barely 3 to 4 minutes between my encounters to kind of prep up for my next patient. So here, the clinical AI agent understands my schedule. It knows who I'm seeing next. It's Sam, who has been my patient for the past year or so. And since it understands the reason for her visit, which is a follow-up for sinusitis, it is able to use its knowledge graph to pull out what are the conditions, other conditions, meds, labs, imaging, those that are relevant to sinusitis, and like pull all of that information into one generative AI produced summary. It's kind of like taking all those needles in the haystack and putting it at a single place, and that's the first thing I see, so that like I quickly get up to speed in those 2 minutes that I have to prepare to see her. So let's see what it says. So it's a follow-up for sinusitis. I've last seen her on the 13th, and it talks about like the relevant imaging, that is the CT sinus. So I guess that looks good. So now I'm about 80% there. So I want to ask a few questions to kind of get to all the understanding before I go into the room. So let's try. Show me her latest labs. All right, it's a live voice demo. Let's see. Cool.
Woohoo, it works.
So it's great that I don't have to go anywhere digging into all the tabs. Traditional electronic health records are like, there's 100 tabs, right? You have to go here and there every time you need something. I don't have to go anywhere. I get all the results right here. Just the abnormals. So conversationally, I can just ask for a filtering of those labs, and it gets me kind of just the abnormals. So looking at these, I guess there are some outliers, but it's okay for what Sam is going through right now. So let me dig in a little more into sinusitis, I guess. How many episodes of bacterial sinusitis has she had the past year? So for this, the agent has to go look into all the discrete and unstructured information in the EHR, both in the health system like my hospital and also all the other hospitals, right? Like these information silos are like really common. Interoperability continues to be an issue in healthcare. So the agent came back. She has had 2 episodes. I can dig in if I want to. So this one, what's going to come up is a more condition-oriented summary. The summary we have seen before is like a pre-visit summary. It's a little more high level. This one digs into bacterial sinusitis a lot more. The onset, what meds have been prescribed, anything else, right? Like that's just like more dense and into that sinusitis thing. What symptoms has she had? So again, conversationally, I don't need to repeat myself that I'm still talking about bacterial sinusitis. It'll hopefully come back to me with like the specific symptoms, so that like I'm 100% prepared and before I go meet Sam. All right, so that's that. So if I go back, hopefully.
Amazing demo. What did this have to do with fine-tuning?
Yes. So that's what I'm going to go, right? So while that experience is powered by a bunch of models, of course, speech models and small to large, like there is a spectrum of language models that are behind that thing. The specific model that I'm going to dive deeper into so that I can answer that question of where fine-tuning and why fine-tuning, I call it the orchestrator. Its job is actually quite simple at face value, which is like take that input, like show me her labs, and actually decide where to route it, right? Sometimes based on all the app context, like what people are seeing on the screen, the conversation history, and the patient context, it has to route to a UI plugin, right? Like what we have seen. But some other times, it has to delegate that request to a search agent that's going to look into notes or other discrete data. So I guess for people familiar with tool calling, we kind of made it a tool calling problem, right? All the UI, APIs, and other agents register themselves as tools. And this particular model, the orchestrator, picks the right tool and extracts the arguments for it, right? So now, let's get to why fine-tuning. Healthcare, of course, takes accuracy very seriously, right? We understand that. But interestingly, this use case cares a lot about low latency. Agent responses, for example, especially the ones where the UI refreshes, right? It has to happen under 800 milliseconds. That's the latency constraint. If that doesn't happen, obviously the users are going to go back to disengage and go back to the UI clicks, which is not the behavior we want. And 4.0 doesn't cut it, right? It takes like a minute, a second, or like 1100 milliseconds. So those 200 to 300 milliseconds that we can save with 4.0 mini is actually super important for us. However, we know that the 4.0 mini doesn't satisfy all the accuracy targets for us. But with as small as like 1500 high quality supervised fine-tuning data set, we were able to kind of fine-tune 4.0 mini to get to the accuracy targets we need. So interestingly, it happens to be latency that pushed us towards 4.0 mini, which needed fine-tuning. Now, I just want to take a couple of examples to show what are we trying to teach it really. It so happens it's all about like how to interpret the rich context to do the tool picking and argument extraction. In this case, show me low priority messages, right? It has to pick the messaging UI and extract priority is low. But a follow-up question, which is unreads, it has to retain that tool, pick the priority is low from the conversation history, but then status is unread from the input. So it's trying to pick and choose like, hey, I'll take this from the input, this from the conversation history. Together, I'm going to come up with arguments. Another quick example, this is about renewing meds. It's renewing, so which means the patient is already on that med. So here, the model has to extract, well, first understand it's the ordering agent and the renew action. That's actually pretty straightforward. But the detail comes into like, hey, I need to extract the drug name from the input, and then I need to go into the specific JSON in the patient order profile to find the dosage, 10 mg, and the route it's called. It's the tablet versus injection versus some other form. And then if it's allowed, that's another key in that JSON. Then it needs to let the renew happen. If that's false, everything else the same, it cannot pick that action. So this is the kind of like complexity of like trying to pick through the rich context and kind of make that decision on the tool choice and action. We started this even before 4.0. So as you can imagine, with 3.5, where the context window is 16K, and our base prompt length without any ICLs in context learning examples is 15K, we had to go with fine-tuning as the only option. But even when we got 4.0, which has 128K context window, it turns out the context is ballooning. Like as you take those bite-sized instructions from fine-tuning and put it as ICLs in the prompt, given the size of the JSONs, right, it actually grows pretty rapidly, which again impacts like latency, time to first token, but also if you went deeper into tool calling, unlike the generative summaries and so on, you can't really do system 2 thinking where you can force the model to output like step-by-step reasoning before it picks the tool. It's an actual technical limitation of tool calling models. So it doesn't work as well. So because it eventually ends up as a rule-based system, it has to pick and choose which one to apply and combine them and so on. So short of it is our evals made it pretty clear that the fine-tuned model candidate is far superior than the prompt engineered model. So hopefully that gave a sense of like our model choices, why we had to go with fine-tuning and so on. And of course, I guess specifically I want to talk about LoRa. We did not want full fine-tuning because of course, like we don't want our fine-tuning to actually erase any learnings that come from post-training. Who knows? OpenAI must have done, actually, while we don't know what they've done, they must have done some training to teach the model tool calling. It's pretty popular. We don't want to lose that. Of course, we want quick iteration. And of course, all of those features are on checkpoints, evals at every checkpoint, and starting with a checkpoint and getting to another checkpoint, all of that is good. And of course, we're going to keep bugging Alicia and the team on more and more customizations. So yeah, so that's it. I guess hopefully you learned something about the model choices and trade-offs.
Thank you. Thank you so much for that. So that was a demo by one of our customers, which is Oracle. And they're showcasing how they're using fine-tuning with GPT-4o Mini because they needed a model that's fast and also accurate. So for accuracy, they decided to do fine-tuning. You can find all the resources on the link as well as the stories around what they're able to achieve. And before I call back Param, next week we'll be having another session around text and speech playgrounds. So next week on Monday, I'll be hosting another session. And this time we'll be talking about how you can use text and speech to build your different models. The next thing is we'll have our AMA, an actual AMA where you can sit down and ask questions to Param on Discord, and it will be on Friday. So if you want to ask any questions, join us on Friday from 1:30 p.m. ET. That is about, I don't know, 8 p.m. my time, I'm guessing. So you can come in and join in and you'll learn a lot. Any questions you ask, you'll come in and learn a lot from them. These are all the files, the links and files you need. So if you want to join our Discord forum, if you want to join our GitHub discussions forum, and if you want to watch live our different sessions, you can click on any of these links, scan them, and join us then. So I'll bring back Param for at least one last question. We have 3 minutes remaining. So yeah, Param is still here. So one of the questions that was asked that I don't think you've answered yet is around, can one get the boundary boxes? It's by Ellie. So can one get the boundary boxes from the output with Azure DI? That's Azure Document Intelligence.
Yeah,
so I'm guessing
that's not
the
us.
question is, yeah, that's
But you can get them with Mistral AI, Document AI, image annotations. So let's come back.
Yeah. Yeah. So I think, I guess you can get them with Azure. Not sure if it's Document Intelligence you can get them with, but you can get them with Azure AI services. Yes. But yes, you've confirmed with Mistral, you can also get them. I don't know if there's any other question you haven't asked, but there's one question that I found very interesting. It was by Andrew Thomas, who's asking if you have, can it break down an image of a handwritten invoice into all the invoice parts? So for example, I know you showed us how it can be able to interpret like from one language to another, but then if you have a handwritten document, like the letter, instead of the letter, it was a handwritten document without even the tables and everything. So can it break all the invoice parts into Markdown, like business, invoice number, total, VAT, and so on and so forth?
Yeah, so annotations are very powerful, but I think this is more a generic document processing question. That's probably how I would start this one. It really depends on the quality, right? Like you can see the model do really tremendous things with like printed, right, and even handwritten. But if it's a crumpled up piece of paper, like we were working with a shipping conglomerate, right, that had very good forms and also some handwritten components, and the model did really awesome job of breaking those constituent parts down and then coming out with the structured output, right? But if I've got something where it's like my uncle, right, who writes like that, obviously no model on the planet has cracked that problem yet, but hopefully we'll get there soon.
Yeah, I think my handwriting is similar to your uncle. And then we have one last question. We have 1 minute to go. So one last question by Nitin Jane, who's asking, what's the guidance on when to use Azure Native Document Intelligence, and when to use Mistral. So I'll just ask you, when should one use Mistral? Because I know for Azure Document Intelligence, you can use it in any of your documentations, and it's mainly when you're trying to do like templating. So if you have already a template you want to use, like if you know it's an invoice and you want to use it to read different invoices, you can create a template for it. If you know it's like the calls you're getting and you want to use a template for it, that's where it shines the most. So in Mistral Document AI, where does it shine the most, basically?
So I would say, like, sort of two use cases. One is I need state-of-the-art OCR, right? And I need just basic extraction, and I showed, a couple examples of that. And the other one's where I have more advanced extraction needs, right? I want to get information out in a really structured way. I want to do things programmatically, and I want to define a schema and just quickly make one API call to do that. We're really awesome at that. And in terms of price performance, I think we're in a really competitive spot in that regard.
Yeah, you can check the pricing details and everything on the links that were shared. But thank you so much, Param. It's been really, really
Thank you.
lovely
This is
having
great.
you. Yeah, it's very good. And I hope we continue this same conversation. So join us
Likewise.
on Friday for AMA. And we'll test out, we should test out some of these use cases live, right?
Why not? Yeah, absolutely.
Yeah, thank you so much. And yeah, have a lovely day, everyone, and see you next week. Bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.